Good morning, everyone. Hope that you guys are having a good start to your day. Hope that everyone got their water or their coffee, whatever they need to wake up. Um, I let's see, there we go. There's the chat. Yep, got the chat going. Okay, I got the chat. I'm about to go full screen, share the screen and everything like that. I am still working on your practice exam. It's coming along all right. I think it will be ready by Friday. And my plan is for that practice exam to be just like a Canvas exam. Wait, no, let me rephrase that. It will be on Canvas, so it will be just like your actual exams. Um, Roughly the same number of questions. That's between 35 and 40. Um, the same time constraints, which we have an 80-minute class. So you'll have 80 minutes for it. And if you think about that in terms of, or I always like to think, okay, we've got 80 minutes, I've got 40 questions. I can spend about 2 minutes on each question. Is every question going to take you 2 minutes? No. Are there going to be some questions that you're like, A, B, done? I know those. Perfect. Or you effectively knock them out in 30 seconds, two questions? Yeah. Will there be a discussion for today's lesson? Um, Discussion. I'm going to post. I've got poll questions that I'll be asking. So in the event that you have to leave early, I'm going to be getting those. And actually, I'm happy that you asked this question. So let me just give you a little bit of an update on poll questions and responses. Um, I like to ask the questions so that I get a response, so that you guys are engaged and interested. And based on the surveys that I got and the responses to the surveys, it seems like everyone wants poll questions. What I'm kind of angling to do now is, as long as you're responding to some of the questions, and I'm not going to give a hard number of like, you have to respond to at least this many. I'm going to give you credit for the day. Now, what I mean by that is, if we have today, I have 9 questions. Um, if you answer one question and then leave, I can see how long that you're in the class, and are you going to kind of slip past me and get credit for that day? Maybe, possibly, probably. Um, am I going to reach out to you and say, hey, I saw that you were online for a minute. I saw that you answered one question. Let's not make a habit of it. Um, so I don't want you guys to be like preoccupied with, I have to answer every single question. I'd like you to. I'd love you to. Um, but I don't want that to be like, I don't know, something catastrophic. Like I was cutting an apple and I cut my hand. Oh my gosh, I should go to the ER. But I've got to answer this poll question. Don't do that. Don't do that. That's not what I'm looking to do. Um, I also don't want you to cut your hand. So at any rate, my point is, if you're responding to some of the poll questions, I'm going to give you credit for that day. I did get an email from someone that I missed their response last Wednesday, so I need to correct that. I apologize to that person who emailed me and I responded. I will fix that today. But what I want with the poll questions is, I want you guys to respond. I want you guys to have some sort of engagement. I want it to be worth your while to come to the lectures. And in addition to that, when we talk about the questions, or that's what I'm going to do. I'll talk about the questions and I'll give you kind of a summary and my thoughts. And these poll questions are going to be worthwhile when it comes to studying for your exam. Okay, so with that in mind, I hope that I answered your question. Um, so anyway, if I did not, please follow up. Okay, so I got poll questions right off the bat. So our first one, I've got 3 that are kind of starter questions. So go ahead and answer this when you get a chance. It's a little bit of a review from last time. This is one of the kind of angles that I'm going to take based on the survey responses. Because last time we were talking about laws, we were talking about John Dalton and Dalton's atomic theory. Um, so matter can neither be created nor destroyed. This best exemplifies which law? Um, Now, there's one other little detail to this law, and that is matter can neither be created nor destroyed in a chemical reaction. The first part of it, though, is pretty much the high point. So we've got about 80 people, or 80% of the people have responded, and I'm going to go ahead and stop this. And again, there's going to be many more polls, so we'll get responses. I want to share the results with you guys on this one. And that is most everyone, 78% of the class responded with the law of conservation of mass. You're spot on. You're absolutely right. Law of definite proportions, remember that's like a definition. So water is always H2O. So it always has a ratio of two hydrogens and one oxygen. Hydrogen peroxide is always two hydrogens and two oxygens, H2O2. Okay, next starter question. Number 2. Which of the following best describes the law of definite proportions? Okay, this is kind of a tricky one. The mass of reactants and products in a chemical reaction remain constant. A given compound always contains the same elements in exactly the same proportion by mass. At constant pressure and temperature, equal volumes of gases contain the same number of molecules. Matter cannot be created nor destroyed in a chemical reaction. So some of those terms might seem a little bit familiar based on, our last question. I can give you 20 seconds left. Now there's about 10 seconds. And that's a minute right there. So seen. Okay. The correct answer is a given compound always contains the same elements in exactly the same proportion. So again, with the word definition, sure, I'll leave this one up. A given compound. So that's saying like, or to draw like a parallel, that would be like saying um, something specific. So this specific compound. And then you can kind of, when you see something like that, I think that it's helpful to say, all right, well, I'm going to insert, excuse me, the my compound of interest. Okay, so water contains the same elements, okay, hydrogen and oxygen, in exactly the same proportion, a proportion similar to a ratio. And then proportion by mass, that's basically just saying related to the overall mass. I'm going to go ahead and stop the share here of that question. Now we've got our third starter question. Let's check that one out. This number typically is not a whole number and ends in a decimal place when you see it on the periodic table. While you guys are answering that, I'm going to go full screen and share what we're doing today. Atomic number, neutroid number, atomic mass, or subatomic particle velocity are our answer options. Or I guess not our answer options, our response options, because these are surveys. And that is a minute right there. The correct answer is atomic mass. You might have also seen that as atomic weight. So in this instance, we use weight and mass somewhat interchangeably. Um, Now, if you think back to like a physics class or something like that, weight and mass are different because weight relates, or is, sorry, your weight on different planets are different because the gravitational force of those different planets. Um, I know you've answered this question before, but are the presentations posted on files or do I'm happy that you asked that question. Um, okay, so I'll come back in just a so mass is basically the constant thing that you've got going. Regardless of what planet you're on, your mass is always going to be the same. Okay, so I got a question about, sounds like navigating our Canvas page. Um, just for context, right now on our Canvas page, and I'm going to switch mine to student view. Um, the way that I navigate our Canvas page is I always do it on my desktop. I don't use the app. I'm going to stop the share of that question. So I don't use the app. I just navigate it on my computer um, in my web browser. And so whenever I go to my course or 1310 and I click on home, this is what pops up for me. And so on a weekly basis, basically I've got it as here's the content from week one. And you'll see the columns. We've got date, recording, activities, section, content. And then if we scroll down to week three, which is what we're on, we'll see January 27th, January 29th. Day four, that takes you to the video. And then I've got the PDF and the PowerPoint file of today's notes. Um, that also links you to, or there's also a column related to your activities. So the activity you need to download, the submission link. And then one thing that I have not yet added is if you look back on the 22nd, there's a day's summary. And that just takes you to a page which I'll bring you back to. I've got to add the one for the 27th, but this just hits on the high points for the day. So important points. On the 22nd, we talked about all of this. And here are some, study guide or basically ideas for how to study that material, just some suggestions and some of the things that we discussed in class. So that is day's summary. I've got to add the one for the 27th and I will add one for today. But anytime you see in this content column, day's summary, that's going to be like your Spark Notes or your summary days. Then I saw another question, but it just disappeared. When is our midterm? Our first midterm is February 12th. So we've got next week's worth of discussion where we'll get new content. Then February number 10th. February 10th, we'll have a review where I'll just kind of hit the high points for that day, or sorry, for that module. And then on the 12th, we'll have our exam. But like I said, you're going to have a practice exam posted to Canvas by the end of this week. Sorry if anyone's had any issues navigating our Canvas page. I did get a request to go through modules, and I am still working on that. So basically, you'll be able to navigate our Canvas page in the coming days, either through home, the way that I've done it, or I'll have it set up. I'm working to get it set up so that you can navigate it through modules as well. Okay. Thank you very much for the question. If any other questions like that pop up, like functional questions, don't hesitate to ask. Okay, so moles. Got a poll question for you. Have you heard of a mole aside from the animals? Yes or no? Some of you maybe took a chemistry class previously, maybe in high school, or maybe you talked about it. I knew whenever I was in high school, the class was called IPC, Integrated Physics and Chemistry. I don't think we talked about it in that class, but all that I remember about that class is two girls got in a fight, and our teacher sat back at his desk and whoa, whoa, whoa. And I remember their names, but I'm not going to say their names because I would hate for any of them to like be a relative to you. Um, so I've got that question still up. Okay, cool. Um, We've got a good number of responses. Most of y'all have heard of a mole, and so here's my follow-up question. Another poll question. What's your opinion of moles? Not the animal. Again, favorable or unfavorable? Okay, this is kind of trending how I expected. Um, just so you guys can see what or hear what I saw, the first three people responded with favorable, and then um, things have shifted. 70% of the class is now saying unfavorable, and that's fine. I respect that. Now, with that in mind, though, a mole is a kind of complicated concept. Um, what I want us to be able to do today is I want to define a mole and molar mass. I want to work through some calculations to convert between moles and mass of a substance. And then that will be kind of a springboard to perform calculations to convert between mass of a substance and number of particles. So we're actually going to kind of start our discussion of moles um, at the end in the set or this third point because we're going to frame moles in the context of numbers of particles. Okay, there we go. Now, what are moles? Okay, well, moles are, kind of by definition, moles or a mole. These are the actual masses of atoms, molecules, and ions, and they are way too small, or sorry, the actual masses of molecules, atoms, and ions are way too small to be used in chemical calculations. So what we do is we scale everything to the standard, and that is a mole. The mole is a unit, and the symbol that we use for it is MOL. I've always liked this MOL because, whenever I think of a symbol or whenever I think of like a shorthand notation, like instead of writing United States of America, I write USA. Okay, that's shorter. That's three letters as opposed to, I don't know, 20 something, 18 something. Um, I like this because whenever I write MOL, man, oh man, I've saved myself so much time and stress because now I don't have to write the letter E. It's a weight off my shoulders, and it's really just fantastic. I sleep easier knowing that I don't have to write the letter E, so that I can write things like 4 mole or 5 mole, saving myself a lot of time. Now, with that in mind, it's to me what's really important whenever you're talking about or thinking about a mole is to kind of take that one step further. And, a mole of something matters. So a mole of blank. That blank could be anything. It could be particles. Okay. Particles is just kind of a filler word for, things. Mole of, let's say, quarters, dollars, a mole of, I still have, I've used this example in, well, I'm going to try to keep this as an example that I'll use in all of my classes. That's a box cutter, a mole of box cutters. Okay. So anytime you hear mole, think mole of what? Now, the molar mass of a substance is defined as the mass of mass in grams of 1 mole of that substance. Okay, so molar mass is something that we're going to get in today, and we're going to do some calculations related to molar mass. Now, what you've commonly heard, or maybe you've commonly heard with respect to moles, is you've probably heard of Avogadro's number. This guy in the upper right-hand corner, I gotta say, he looks very suspicious. He's like, what's going on here? His name is Amadeo Avogadro. And he cooked up this number, and this was not like an arbitrary number where he's like, I think it should be this. But he said, and this has continued to be used, is that the number of representative particles, or Avogadro's number is the number of representative particles in a mole. The number of those representative particles is 6.02 times 10 to the 23rd. Done. Yep. Now, when thinking about that and looking at that number, that's a number we've seen before because we talked about scientific notation and complete notation. And so when you think about that number and you see that number, we've got a little poll question related to that. When you see the number 6.02 times 10 to the 23rd, the exponent is a positive number. What does a positive exponent mean for the direction you move the decimal? Basically, what I'm asking, or another way of asking that is, how would we convert 6.02 times 10 to the 23rd, which is denoted in scientific notation? How would we convert that to from scientific notation to full notation or complete notation? Am I going to move my decimal this way? Or am I going to move it this way when I have a positive exponent? Now, we're looking at about a minute done there, and 80%, 81% of the class. I'm going to go ahead and stop right there. About 77% of the class is correct. They said move it to the right. One person said it means nothing. And a couple of people said that they move it up. I know that's really tempting because that little symbol right there, that kind of arrow looking symbol, looks like it is. Oh yeah, you move it up, you shoot the decimal straight up, you get rid of it. Not quite. So we'd move it to the right when you see a positive exponent. Now, what I recommend is to think of this number as a conversion factor. And if you've heard of a mole before and you've heard of conversion factors, chances are what I'm about to say is not really new information for you. This is similar to a dozen. When you have a dozen of something, you've got 12 of that thing. Now, a dozen is a representative number. So you've seen that. You've talked about that any number of times. And whenever I say something like, you have 3 dozen baseballs, you know what that means. Okay. In addition to that, if I were to say, you have 13.5 dozen nails, okay, and not fingernails, like construction nails, you would know what that means. So you would, I think everyone in here would be able to kind of say, okay, well, I'm going to set this up. I'm going to use this right here, 13.5 times, let's see, this would be, let me go ahead and write this out a little bit more. 13.5 dozen nails. If I were to do this calculation, what I would do is I would say multiply by, and then I'm going to put parentheses for my conversion factor. My conversion factor is that 1 dozen nails is going to be in the lower portion of this fraction. It's going to be in the denominator. Because then whenever I multiply this number right here by whatever is in this parentheses, what's going to happen to dozen nails? Add to the chat what's going to happen. Actually, let me go ahead and say 12 nails. I got a couple of responses that it's going to cancel out. You're absolutely right. So whenever I take this number on the left, 13.5 dozen nails, and multiply it by 12 nails over 1 dozen nails, well, I've got this unit, dozen nails, that will cancel out. Now, if you've taken a chemistry class before, and I talked about it a little bit previously, dimensional analysis. That's a really fancy term. And that's a really not straight line. That's better. To take this information with these parentheses and write 13.5, I'm going to write DZ, dozen nails, and then 1 DZ nails, and I'm going to write 12 nails and set that equal. I multiply across the top and then divide by whatever is on the bottom. 1 is on the bottom. So even though I have it, I'm stressing this one because even though I have a decimal place, even though I'm not dealing with a whole number right here, I can still work with that because I can say 13.5 times 12 is a number that I'm going to find out once I punch it into my calculator. And somebody else is probably going to, how would I get my calculator? Dun, dun. There we go. I'm sorry. I'm sorry. 162. Thank you very much. Just to put any sort of concerns at bay, this right here is pretty much the most complicated that our dimensional analysis gonna be. You're not going to have tons and tons of questions like this. Whenever you take your exam, don't expect 40 dimensional analysis problems because then this would not be a chemistry class, this would be a dimensional analysis class. And that's not what I'm looking to do here. So be patient with yourself and be patient with me, please. Okay, so that's what we're doing. We've got a 13.5 dozen nails. Just like in a moment, if I were to say you have 3.5 or 0.5 moles of something, you take that and convert. Okay. Can I get a thumbs up or a yes if they're like, okay, I follow up to this point? I got a lolly. LOLLL. Okay. 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 All right. It's cool. It's cool. All right. Thank you guys very much for responses there. Now, we're effectively translating. So this is like, to me, one of the most important things to understand. Um, I gotta be honest with you. I like chicken wings. And so one of the things that's important to me about chicken wings is the correct blue cheese. That's just a little bit of an aside. But I want to use these problems right here. Say that you have a dozen. Oh, great. Okay, I got a private message. Why didn't you divide by 1 dozen nails? We use that as a unit of measure and leave it. Basically, yes. So if we were to jump back here, we would have 162 divided by 1. Well, 162 divided by 1 is 162. And I got a private message of, are we going to be able to use a calculator during the exam? Absolutely. But the 162 is in nails, not dozen. That's absolutely right. I think that no, I'm getting private messages from someone who said no, it's 12 nails on bottom converted. No, we don't need to do that because what we're doing is we're trying to walk from, find a relationship that we can cancel out. We had dozen nails up here, and so we need to relate dozen nails to something else. 1 dozen nails is exactly 12 nails. Okay. So for my chicken wing example, this is one of the kind of complicated or complex aspects of these sorts of problems. Now, if you have 12 or sorry, 1 dozen buffalo seasoned chicken wings, there are a couple of things that you can do and think. First of all, How many wings is that? Well, we know that this representative number, dozen, means that we have 12 wings. Okay. Now, in addition to that, there's a couple of different ways that you could go. One way that you could go is I know that in the chicken wing world, and I hope that someone can follow me on this, and we're going to come back to this sort of example, not this specific example, but other food related examples with, well, there are two different types of wings. There's flats and there's drummies. Let's ignore drummies for a moment. And that's flats, F-L-A-T-S, not flaffs. Flats. Now, what a flat is it kind of looks like here's one bone and here's another bone. And they connect here and here respectively. So if you have 12 wings and all of them are flats, how many bones are there? Answer in the chat. How many total bones are there if you have nothing but flats and you've got 12 of them? Mm-hmm. I got 24 is the answer that I'm getting a lot. Because what we're having to do is I'm saying we've got 12 wings. All of them are flats. What are those flats made up of? And if my question is how many bones are there, then you kind of have to dissect that thing. Okay? Now that's something that we're going to be talking about as the semester proceeds, related to moles. Okay? Now we could also go in a different direction and find these sort of relationships. So everything related to moles, you've got to be able to figure out how to convert and how to process different conversion factors. So if you were to see this question, how many chickens were required to make these? Now, I'm going to draw a chicken real quick, and you can answer in the chat. Um, my chicken's probably going to look a little bit like a turkey. Okay, I got votes for 12s. Now think about birds in general. I'm seeing lots of sixes now. I see 66. I think that was okay. So I got a couple for just flats still. Well, just so everyone, okay, so let's see. I'm gonna draw a wing. Yeah, that's a wing right there. How many wings does a bird have? Each bird has two wings. Perfect. And this wing, the anatomy of it, one part the manufacturers use to make a the flat, and then the other is the drummy. I think. I don't know exactly. But the point is, the answer to this question, how many chickens were required to make these? Well, each bird has two wings, and each wing has one flat. So that would be 6 chickens. Because one chicken, and just so everybody knows, I'm not going to be asking questions where I need you to have prior knowledge of chicken anatomy or anything like that. But here's my logic. One chicken, two wings. And one wing has one flat. So we've got our connection here. Well, if we want to get 12 flats, then we have to have a couple of, and I'm going to draw this as dimensional analysis. And this is a little bit more drawn out, but follow me here. 12 wings, or I'm going to just go ahead and say 12 flats. Well, I need a relationship between flats and wings. So one flat per one wing. Okay, so that relationship is done. Now, two wings per one chicken. What does this equal? Well, 12 times 1 is 12. And then I can divide that. I'm going to divide that by 1 times 2, or 12 divided by 2. 12 divided by 2 is 6. So 6 chickens. Okay. All right. Now we will proceed from there. And we're going to have some more examples like that. And not specifically like chickens and chicken anatomy, because that's a lot. Molar mass. Molar mass is the mass of 1 mole of a substance. Now, the conventional units for this are grams per mole, or G per mol. Now, this is equal, or sorry, to determine the molar mass of a compound, what you need to do is add the masses of the elements in a compound. Where are these masses coming from? Add to the chat where the atomic masses or masses of atoms come from. Where can we see them? Where's a good reference? The periodic table. Perfect. Because the periodic table, we're going to see the atomic number. I like it, Emma. The atomic number as well as the atomic mass. Now, what the periodic table that I always like to use is ptable.com. So I'm going to switch my share. This is what I think is a really good reference for, a periodic table if you're looking for one. We've got fluorine. Every element that you hover over, it's going to bring up important information about that. For instance, the symbol SN corresponds to the element tin. Oxygen, well, 15.99 is the atomic mass there. And so with that, I've got a pair of questions that pop up. So there's 2 questions. Go ahead and answer these. Or sorry, you should be able to see 2 questions. And remember, keep straight the atomic number and the uh, uh, atomic mass. And for the second question, you might think, oh, well, I need to round. Or if you think I need to round, yes, you can go ahead and round. Just use the closest number to what you believe is the answer. Giving them, I'm going to give a little bit more than a minute, and then I'm going to switch my share. This is ptable.com if you ever want to pull that one up or need a good reference. That's, quickly available. Then switch back to that. So my 2 questions here were about oxygen. Oxygen, if you look at it, the symbol for oxygen on the periodic table looks a little bit like this. We've got the atomic number, 8, the symbol, O, and then the atomic mass, 15.999. Okay, so your first question was, what's the mass of 1 mole of oxygen? And you know what? 81% of you answered right. You said 15.99. The next question was, what is the mass of what is the mass of 1 mole of oxygen gas, or O2? Okay, when you see O2, when you identify O2, well, what do you have? You have 2 oxygens. Those 2 oxygens, that means 15.99 times 2. So 70% of you guys answered correctly that the mass of 1 mole of O2 is 32, because he said 15.99, which is basically 16, multiply that by 2, got 32. Great work on those. Now I'm going to close that poll, and we are going to go on. And what we're doing today in class and what we're going to be introducing is some conversions, because moles are a tough animal to crack. There's a lot to process with these. So I didn't want to say, oh, well, we're done with moles and then let's continue. Let's just breeze through moles and go on. I've got another poll question for you. If you have 1 Oreo cookie, you have 1 mole of Oreo cookies. 1 Oreo cookie cannot be determined from standard methods. A baker's dozen of donut holes. I am no longer interested in currently seeking out a nice sugary snack. At least a Pop-Tart or something good. Something breakfasty. Start your day out right and whatnot. I really didn't intend for that to be the popular answer, but that one's rising to the top. And I think by saying that, that's just encouraging more people to give that answer. You're welcome. You're welcome. Okay. Okay. Well, do not do Pop-Tart or whatever you're allergic to. Eating an Oreo right now? Okay. Respect. So the purpose of this is, I think that Oreos are kind of relatable. It's something that you know what it consists of. And there's any number of other things that people use to illustrate this. But if you have 1 Oreo, you have, well, basically 2 wafers and 1 Oreo filling. Now, if you have 1 mole of Oreos, again, we've used that representative molecule or representative number. If I had 1 dozen of Oreos, you have 12 Oreos. These 2 terms, I want you to see these things as being very similar to one another so it can make it a little bit more relatable and processable, because I always struggled with a mole because it was such a massive number that I was like, I don't even know how to think about that. Now, if you have 1 mole of Oreos, well then, you have something a little bit different. You have 2 times 6.022 times 10 to the 23rd Oreo wafers. Okay. Why did I say 2 though? Why did I add this 2? Add to the chat why I added that 2 there. 2 wafers per Oreo. So if I have 1 mole of Oreos, well then another way that I could put that is I have 2 moles of Oreo wafers. Then, okay, if you have 2 mole of Oreos, how many Oreo wafers do you have? Well, you've got to remember, you have 2 moles of Oreos. How many wafers are there per 1 mole of Oreos? You have 4 moles of Oreo wafers. So you'd say 2 times 2 times 6.02 times 10 to the 23rd. What I would encourage you to do whenever you see problems that ask you about moles is switch the number. Substitute mole for dozen, just so you can wrap your mind around it. I think that's a really good way to practice understanding this number. I got a private message of, wait, so 1 mole is a dozen Oreos. No, it is not. I'm using dozen to be a definition. So 1 dozen is 12. So 1 dozen eggs is 12 eggs. 1 mole is 6.02 times 10 to the 23rd. I'm going to go ahead and do this. I'm going to write this number out in its complete notation. 602. This right here, this number is 6.02 times 10 to the 23rd, written in complete notation. So 1 mole, this is equal to 1 mole. So if somebody says, I have 1 mole of Oreos, actually erase some of these things. One mole of Oreos is the same as 600. I think the number is actually 602 octillion. More than a billion, more than a trillion, more than a quadrillion, pentillion, hexillion, septillion. I think it's 602 octillion. This is what I mean whenever I'm talking about a mole definition. Okay. So I want to draw a line around this to keep this separate as well. 1 dozen Oreos is still 12 Oreos. 1 mole of Oreos is 602 octillion Oreos, or 6.02 times 10 to the 23rd Oreos. A massive number of Oreos, a massive number of anything. Now, what we also want to be able to do is calculate a molar mass. So we need to be able to identify a chemical formula and find the mass of the atom on the periodic table. We did that with the poll question where we were asking about oxygen. O versus O2. What's the difference? Now, what we're going to do after that is we're going to multiply each element's atomic mass by the number of atoms in that formula. Then we're going to add all those values together to get the molar masses. Now, just to give you a sense of what this is going to be, whenever you're doing a molar mass calculation, I think that it's a good idea to have an expectation of your result. A molar mass, chances are, is going to be, I feel comfortable saying between 30 and 1,000 grams per mole. I put 1 there just to give, like, illustrating that it's a whole number, or it's, sorry, not a whole number, but it's a number greater than 1. Now, if I said, what is the molar mass of, let's go with H2O2. What I would do is I just look at the numbers on the periodic table. And I say, well, H, the molar mass of hydrogen. Would anyone care to add what the molar mass of hydrogen is to the chat? 1.008. We've got 2 of them. I'm going to round that down to 1. And so what I'm going to do is I'm just going to say 2. Plus, what about our molar mass? And we can round this to a whole number for oxygen. 16. So 2 times 16 is 32. So the molar mass of hydrogen peroxide is approximately 34. Okay, easy peasy. We just look at the periodic table, which you're always going to be given a periodic table on your exams. And we're done. We're good to go there. Now, this is a molar mass calculation. There's another way to look at these because you can use molar mass as a conversion factor as well. So there's this term stoichiometry. This is something that is basically just a relationship between amounts of substances in a chemical reaction. We're going to get into these and we're going to get into them later. So for the time being, just keep that term in the back burner of it's a relationship or it illustrates ratios. But now what we're going to do is we're going to go back to cookies. Okay. If you eat an Oreo and your friend eats a Chips Ahoy, have you both eaten one cookie? You eat one Oreo, they eat one Chips Ahoy. Have you both eaten one complete cookie? Yeah, you have. There's no real debate there. Now, let's say one Oreo has a mass of 125 grams. What that means is you got an Oreo and put it on a digital balance or a digital scale. And you figured out that one Oreo is 125 grams. And then let's say, oh, that's not what I want to do. Let's say that one Chips Ahoy has a mass of 195 grams. Okay. You have both eaten one cookie. Who has eaten more? Who has eaten a greater mass of cookie, you or your friend? Your friend. Your friend ate 195 grams of cookie. And we're trying to draw a relationship between and a common definition of you've each eaten a cookie. Now, let's say that you eat 195 grams of Oreo. This is a strangely worded question, but how much Oreo did you eat? Have you eaten at least one complete Oreo? Haley drops the 1.56 Oreo. Yes, you have eaten absolutely more. I'm not familiar with the Cookie Monster and Siri question. Okay, fair question, Daniel. We'll go with yes. Okay, so now what we're doing is we're taking masses and drawing that as relating masses to individual units. So the masses of your cookies are different. And so if you both eat the same mass, like if you both eat 195 grams of cookie, your friend has only eaten one complete cookie and you've eaten 1.56 cookie. Why is that? Because the mass of those two cookies are different from one another. Now, if your friend eats 195 grams of Chips Ahoy, they've just eaten one cookie, one complete cookie, that's it. This is a relationship. Think about the cookie as kind of a conversion factor of sorts. Now, mole to mole relationships are very similar to this. Think about moles almost the same way that we're talking about cookies. Each cookie has a different mass, just like every compound has a different mass. So let's go back to, we'll use H2O2 versus H2O. H2O2, we determined that the mass was 34 grams per mole. And H2O, I'll save anyone the looking at the periodic table, is about 18 grams per mole. Now, if you have, let's say that you and your friend both get a beaker, and in that beaker, your friend places 18 grams of water, And then in your beaker, you place 18 grams of H2O2. Who has exactly one? I'll illustrate this. 18 grams H2O2, 18 grams H2O. My first question is, do both of you have 1 mole of your specific substance? I got a vote of no and I got a vote of yes. Your friend has exactly 1 mole of H2O. But we know our definition for H2O2. How much H2O2 do you have to have exactly 1 mole of it? You're absolutely right, Lisa. No, we don't. If we have 18 grams of H2O2, we don't have 34 grams of H2O2. So I'm going to go ahead and add here less than 1 mole. Can anyone add a yes or a thumbs up or anything like that to the chat if they follow this? Okay. 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 I've got some private messages of no. So we're going to work through a couple of examples. Now, we're going to, I'm going to go ahead and skip ahead. I'm not going to do another cookie example, despite liking cookies. I'm instead going to pivot and we're going to use specific compounds because chances are this is the sort of thing that you'll see more on an exam than cookie questions. Um, thank you. So what we have here is specific masses, NaCl versus NH3. Now, I can toggle back and forth between the periodic table. I'll just do it on my computer. Okay, have a good one. Um, so NaCl, if I look at that on the periodic table, I'll see that sodium has 22.9, which I'm going to round that to 23. And then chlorine is 35.45. So I'm just going to round that to 35.5. So whenever I look at the mass of NaCl, I'm looking at approximately, it'd be 58.5. So if I have 58.5 grams of NaCl, which, this is table salt, that means I have exactly 1 mole of NaCl. NH3, well, nitrogen has a mass of 14.007. I'll call that 14 even. And then hydrogen has a mass of 1. So I'm going to call this 17 grams. That I got a private message of, is rounding typically what we will be doing on quizzes and tests? Yep. And usually the way that I kind of like to direct you to that is what we saw earlier in one of our poll questions. I'll give you, my question will be something like, select the best answer. And there's going to be like, when we were asking about O2, it was 32 was a possible answer. You didn't see 31.98 or anything like that. So I think that whenever you're headed in the right direction, the best answer option is going to be the one that's there, and that's going to be rounded. Okay, so this is a cleaning product. Okay. Ammonia is what that is, or it's an ingredient in many cleaning products. So if we have 58.5 grams of NaCl, we have exactly 1 mole of NaCl. If we have 17 grams of NH3, we have exactly 1 mole of NH3. Okay, these right here, we just got that from the periodic table. Will you see a question on your exams, or will you see questions on your exams that just ask you to calculate the molar mass of a substance? Yeah, absolutely. That is, to me, that's like your foundational question. And I want you to answer those foundational questions correctly because then when we go to a next level question, you're kind of leveling up each time. So to answer a molar mass question, it's navigating the periodic table. And if you can navigate the periodic table, you're going to be in good shape for that. Okay. Now, a next level question might be something like, and I'm going to come back to the one that's prompted. I got a private message of where did I get the 58.5 and the 17 from? I was toggling back and forth in my browser um, for the periodic table. So the 58.5 and 17, I got those directly from the periodic table. So the mass of Na is about 23, Cl is about 35.5. I added those together to get the 58.5. So I'm just going to, these numbers, I'll say periodic table. Periodic table. Table, not fable. Okay, so my first level is calculating a molar mass. So 1 mole of a compound is always, yes, it is. The units here are important because molar mass units are grams per mole. All right, now my next level question. So I'll say that this is first. My next level question would be, what's the mass of 2 moles of NaCl? And I'll ask you guys to add to the chat the answer to this. What's the mass of 2 moles of NaCl? Done, done, done. Yeah, 117. We took this right here, this definition, and we multiplied it by 2. Okay. How are we feeling about that? So we looked at the periodic table, we added some numbers up, that gave us our molar mass, and then we took whatever number and related it to that definition. Whenever I say whatever number, my statement is like whatever number of moles. You know, if I had said, what is the mass of 312 moles of NaCl? What would you do? You'd take that 58.5 and multiply it by 312. Now, would that give you a big number? It would, and that's okay. Okay, now, thank you, Haley. I trust you on that one. So thank you very much. 18,252 grams. Great job. Okay, now, this is a slightly different way to think about it. What if you have 550 grams of NaCl and 550 grams of NH3? Which of those two things do you have more moles? Okay. Now, one of the ways that we can do it is I'm getting some votes here of NaCl question mark, NH3, NH3. Yeah. We'll take these 550 divide by 58.5. I got one comment of 9.4 moles, private message 9.4 moles NaCl. And I think that my number of moles of NH3 are probably coming soon. 550 divided by 17. Sorry for putting somebody on the spot who's sending me the private messages. I didn't do this calculation yet. I was just planning on doing it as a group. So 550 divided by 17, it's north of 20. I'm just going to go ahead and say, let's say 33. I use the tilde there in front of my 3 just to be like, yeah, more than. Oh, 32.3. Okay, perfect. 32.3. Okay. So this question right here, 33.4. Okay, well, I'm gonna go with 30 something. I think, yeah, I think it's 30. I don't know. I don't want to sound like I'm favoring one person over the other. That's not what I'm doing. Okay, now I'm getting lots of 32.3, so I'll go back with the 32.3. Okay, so we had our first level, just looking at the periodic table. You're going to see a question like that on the exam. Our second level is, here is the number. What is the mass of that number of moles? So that's looking at the periodic table and then multiplying. And then this right here would kind of be your third level question. You should expect that question. Not that exact one, but that sort of question. Now, one of the things that makes this question a little bit more complicated is you're given information and then you kind of have to, well, answer a yes or no question. Because this wasn't, well, how many moles of each? You had to solve that. But I wasn't asking you to tell me how many moles of each one of them. Now, whenever I say I wasn't asking you to tell me that, I mean, you could see this question, this third level question, phrased on an exam as, select the true statement. And that true statement might be, you have 9.4 moles of NaCl. It might also be, you have 32.3 moles of NH3. Or this question could be, which of these two substances do you have more of? And at the end of the day, what was the central part of solving this problem in these three different levels? Well, it was determining the molar mass. So referencing the periodic table. Okay, I've got one last poll question I'm going to launch right now. And then what I'm going to do is we're going to stop right here with our new content because we've gotten pretty deep into moles and they are complicated. So I've given you a scenario. One of your friends placed a 500 ml beaker on a digital balance. This beaker can hold a solid, and chances are it could hold as much as 500 grams of most substances. Your friend is going to weigh out 3 moles of NaOH. But before they do, they want your opinion if this substance will fit into the beaker. What do you tell them? You say, yes, you'll have no problem with the solid and the piece of the glassware you selected. I figured this out by calculating the mass of 1 mole of NaOH with the numbers straight from the periodic table. You're good. Oh no! That piece of glassware isn't large enough. You'll need to get a different one. I know this because 1 mole of anything has a mass of 6.02 times 10 to the 23rd grams. I forgot G there, but grams is what it would be. Now, to give you a little bit of a direction on this one, we're trying to figure out, do we have, with 3 moles of NaOH, do we have more or less than 500 grams? So that's referencing an amount, which is similar to this third level question that we just saw. In order to answer that, we've got to look at the periodic table. And I'm going to go ahead and go to the next slide so I can work this one out with you guys. Or we can kind of work it out. I'm happy to see the responses, but here's our question. 3 moles NaOH. First of all, 3 moles of NaOH, well, in order to worry about that number, and we're asking about the mass, 1 mole NaOH is, and I just kind of remember these numbers from the periodic table. If you look at the periodic table, you'll see that sodium has a mass of, I'm going to call it 23. Oxygen has a mass of, I'm going to again simplify it, say 16. And then hydrogen has a mass of 1. So our total there is going to be 40 grams. 39.99. Perfect. So 1 mole of NaOH is 40 grams NaOH. Now, once we've solved that, the question is, do we have more or less than 500 grams. And the quantity that our friend is curious about is 3 moles. I got responses. We have less than 500 grams. And you're absolutely right. We have less than 500 grams because we only have about 120 grams. So this times 3. Great job. Great job. Now, the alternative answer. So our answer was yes, we're fine. I'm going to say yes, dot, dot, dot. The alternative part of it, what was the problem with that statement? What was the biggest issue? Is 1 mole of anything, does 1 mole of anything have a mass of 6.02 times 10 to the 23rd? No. If I have 1 mole of NaOH, our question was asking about mass, not about. So 1 mole of NaOH, think about this as I have 6.02 times 10 to the 23rd NaOH particles. I'll say molecules. And the mass of an individual NaOH molecule is so low. So that was kind of a decoy question. It threw the number in, or that was a decoy answer. It threw the number, that's 6.02 times 10 to the 23rd. It threw that in, but that wasn't needed for this calculation. What I want, okay, so I'm going to go ahead and end this poll. I can go back. I'm going to stop my share. What I want you guys to think about with respect to, kind of important takeaways for today's lecture. I want you to think about the periodic table as a very useful tool. I want you to be able to calculate the mass, the molar mass of something using the periodic table. So reference the periodic table and see, okay, if I'm asking about mass, this is the number that I need to get. If I'm asking for the molar mass of something, well, I need to figure out all of the different symbols and then add them up. So be able to calculate molar mass. So if I have 1 mole of something, what's the mass of that 1 mole? If I have 2 moles of something, what's the mass of those 2 moles combined? If I have 500 grams of something, I want you to be able to do the kind of back calculation to figure out how many moles of that substance do you have. So going from um, mass to moles and moles to mass. That's what I want you, that's the important takeaway from today. I got a private message of, will we have a periodic table on the test? You absolutely will. It's I always include the periodic table. I just do a screenshot and put that in for the questions that need them. Um, with that though, thank you guys very much for coming to class. I've got office hours at 12:30 if you want to join. I'll be posting the notes or kind of my summary notes from today's meeting. I'll post the recording a little bit later today and be patient with yourself with moles. Thank you guys very much, and thank you for your patience with my Oreo and chicken wing models. Let's see. The practice exam will have, it's not unlimited, it's 999 attempts. Okay, and then, so pretty much. And if you use all 999, I can reset them and give you more of them. Thank you guys. I'll see you guys on Monday.